So let's say we want to use the density of an object in order to calculate its volume. Let's take an element like mercury. Mercury is an incredibly dense element, and we can see on the table over here that mercury's got a density of 13.6 grams per centimeter cubed. And we can use this information to calculate something like the volume that 20.4 grams occupies. So 20.4 grams of mercury occupies what volume? We need to go back to our definition. Density is mass divided by volume. So if we want to find volume, then we rearrange. Volume is mass divided by density. A simple way to rearrange these kind of equations is just to sort of cross multiply. So if you've got density equals mass divided by volume, you can always bring the bottom of one side across to the top of the other. So in this problem here, there is density times volume is equal to mass. There's really nothing down here at all to bring over. And then all you got to do is just divide by whatever it takes to get the one thing isolated. So if you're just looking for volume by itself, you need to divide both sides by density in order to cancel out the density term on the left. So that gives you volume is mass over density on the right. And conversely, if you were solving for something like mass, then you would take this equation over here, density times volume equals mass, and you'd already have it figured out, wouldn't you? So mass is density times volume. So that's how you quickly rearrange these equations. So let's go ahead and finish off our calculation. We want to know what the volume is. Volume is mass divided by density. And so the mass is 20.4 grams. Density is 13.6 grams per cubic centimeter. And if we just punch those numbers in our calculator and avoid writing too many digits here, we get something like 1.50. Now the units are interesting, so you can go ahead and you can probably guess that the units for volume are going to be centimeters cubed, but we can see why this happens. So we've got grams on the top and we've got grams per cubic centimeter on the bottom. And if you remember, when you divide by a fraction, that is the same thing as multiplying by the inverse of that fraction. So dividing by grams per centimeter cubed is the same thing as multiplying by centimeters cubed per gram. And then it's easier to see the grams cancel out and we're left with centimeters cubed. So the volume would be 1.5 centimeters cubed. Now, that's pretty amazing if you ask me, because, 20.4 grams, that's 2/3 of an ounce. It only has a volume of 1.5 centimeters cubed, so that's just an incredibly small volume, and mercury is incredibly dense, so that mass is packed into a tiny, tiny volume. Now let's do the reverse problem. Let's say we want to have 100 centimeters cubed of gold, and we want to figure out what mass this is going to be in grams. So we can solve for this problem the same kind of way. Density is mass over volume. As we saw before, mass then is density times volume, and so the density of gold is 19.3 grams per centimeter cubed, so 19.3 grams over centimeter cubed. We multiply by 100 centimeters cubed. We can see the centimeters cubed cancel out and leave us with units of grams, which is perfect. And multiply by 100, so that's going to be 1930 grams of gold. So that's almost 2 kilograms, occupies a volume of 100 centimeters cubed. I think this is incredible when you think about it, because 100 centimeters cubed of water would actually only have a mass of 100 grams. And you can see if you go to gold, it is 19.3 times heavier. So that's incredible. So gold has 19.3 times as much weight in exactly the same volume as water does. So it's incredible. If you were made mostly of gold instead of water, then your weight would increase by almost a factor of 20. So if you weighed 100 pounds, if we swapped all the water in your body for gold, then you would weigh something on the order of 2,000 pounds. You'd weigh, gosh, a ton. So what an incredible difference it makes going from the density of water to the density of gold.